Let's go to a more advanced concept on finding out the digits at the tens place. This is far more complicated. So listen to me very attentively, and we are going to form some rules through which we'll be able to find last two digits for any given number. I'll give you some methods you can find out for any given numbers, but we'll obviously break it down into parts. Okay. So first, understand that there's no single rule. Like we had last digit cyclicity. So each digit either has a cyclicity of 1, 2, or 4. There's no such singular rule for last two digits or for the tens digit. Okay. We'll have to find it through a slightly more complex method. Also, the last two digits of any number is also the remainder when the number is divided by 100. I hope that obviously you understand. So for example, if I ask you 12 to the power 2, what are the last two digits? So 12 to the power 2 obviously is 144. 144 I divide by 100. My remainder is 44. So the last two digits are 44. This concept also we use sometimes. Okay, so we divide by 100 and we find out the remainder. Okay, then we'll use some bits of binomial theorem. So just to do a recap of binomial theorem, the binomial theorem basically is used in expansion, and I hope you remember that. So just to do a recap, any number of the type a plus b to the power n can be expanded, and this is the binomial expansion. Okay, you start with NCR a to the power n minus r b to the power r. That is the formula that we use. So for example, if you have a plus b cube, okay, so then n is equal to 3 here. So your first value will be NCR 3C0. R starts from 0. So 3C0 a to the power n minus r. So a cube and b to the power 0. Then 3C1 a square b plus 3C2 ab square plus 3C3 a to the power 0 b cube. As per this is the formula. You start with NC0 and you end at NCN. Okay. Now this, if you see, 3C0 is equal to 1 basically. So you get a cube. Then 3C1 is equal to 3. You get 3a square b. Then you get 3C2 is also 3. You get 3ab square. And 3C3 is also 1. You get b cube. So essentially you are getting a cube plus b cube plus 3ab into a plus b. And this, I hope you remember, is your formula for a plus b cube. Okay, so this is how this binomial is useful in finding out the last two digits also sometimes, which you'll see in the questions going forward. Okay, so let's jump into the rules and listen very attentively. Okay, so first, let's say I have to find the last two digits of this number. Okay, now this can be done using a variety of methods, but I will use the method which we discussed just now here, divided by 100. Okay, so using that concept, 299, why am I using that concept? Because you can see 299 is very close to a multiple of 100, which is 300, right? So 299 to the power 33 can be written as 300 minus 1 to the power 33. And this if I divide by 100. Okay. Now, if you remember the binomial here, you see here the last term of the expansion will be what? Which will be, and the last term is the only term where a will not come. It will be only b, right? A will not come because the expansion of this will start with what? 33C0 300 to the power 33 into minus 1 to the power 0. That is what you will start with and end with what? 33C33 300 to the power 0 and minus 1 to the power 33. What will come before this? 33C33 32, 300 to the power 1 and minus 1 to the power 32. Okay, so you're basically, this power goes on reducing and this power goes on increasing. Okay, so these will all be all the terms if the expansion. Now if you see, as long as the expansion has 100 or multiple of 100, that will get fully divided by 100. So you can see that till here, this term has 100, till here you have 300 to the power 1. So this all will get fully divided by 100. What will not get divided is only this part, is only the last part, because here it is 300 to the power 0. That means 300 to the power 0 means 1. So this term is 33, C33, which is again 1. So it is 1 into minus 1 to the power 33, which means it is essentially minus 1. And all other terms before that have got divided. So what you'll be left with the numerator is minus 1 divided by 100, which will give you a remainder of minus 1. Okay, so that is where your binomial is very useful in certain questions. Now remainder cannot be negative. Theoretically it can be, but in maths your remainder cannot be negative. So if you get a negative remainder, what you do to that remainder is basically you add the divisor to it. So 100 is my divisor, I'll add to minus 1. That means my final remainder is going to be 99, which will be the last two digits. So my answer for this question will be 99. Okay, so I hope you have understood, and I hope you have understood how we have applied binomial here and how we have applied the 100 divisibility concept here, which we just discussed in the previous slide. Okay, so that's how this question can be done. There's another method also of doing this question, which will come in a bit, but some certain questions where you see like this, you can apply this concept and use, because dividing by 100 is very simple, because the last two digits will be the remainder, and that will also be the tens digit and the units digit of the number. Okay, fine. Let's dig into the concepts now. And what we will do is, first we will look at when the last digits are 0 or odd. Okay, and then we'll look at when the last digits are even. So we'll look at all numbers, we'll look at all possible combinations, and at the end you'll have answer for every case. Okay, so for numbers ending with 0 or 5, 0 is very simple. The last two digits will be 0, 0 for any number that has 0 at its units place and is raised to any power. So if the units digit is 0, it does not matter what is the tens digit of the number. It does not matter what is the power. It will always be 0, 0. Okay. So 1, 0 is very simple, clear-cut case. For example, if you have 130 raised to the power 24, it will end with 0, 0. If you have 130 raised to the power 25, then also it will be 0, 0. Okay, then also it will be 0, 0. So 0 is the simplest case. Then comes the case of 5. In case the last date is 5, then there is a pattern, and this you need to remember. If the last date is 5, the tens digit is even and the power is also even. For example, 125 raised to the power 24. You can see the tens digit is even, power is also even. Then the last two digits would be 25. When the tens digit is even and power is odd, then also the last two digits are 25. Okay, so as long as the tens digit is even, power does not matter, you'll have 25 in the end. Okay, when the tens digit is odd and power is even, then also the last two digits will be 25. Okay, so instead of 2, you can see we have 3 here, which is odd, but the power is even, still you'll get 25. The only case where you do not get 25 and you get 75, so it might be better to remember this. This is an odd combination. So odd is the only combination where you get 75. Otherwise for 5, it is always 25. Odd. What does odd mean? The tens digit is odd and the power is also odd. Just remember that. Easier to remember. Odd into odd gives you 75. Okay. So the tens digit is odd. The power is also odd then your last two digits will be 75. Otherwise, it will always be 25. Okay, so these are the rules for 5. Let's look at then numbers ending with 1. Okay, and this is very important because for all odd numbers, even for even numbers, finally we'll bring it to number ending with 1. Okay, so we are going to use this a lot. The last digit of a number ending with 1 is obviously 1 because 1 has a cyclicity of 1. The second last digit, now remember this, the second last digit of is the units digit of the product. Units digit of the power is multiplied with tens digit of the number. Okay, for example, we have 31 to the power 76. Understand this very carefully. 31 to the power 76, last digit is obviously 1. Okay, the second last digit will be the product of the units digit of the power. So for the power, you take the units digit. And for the number, you take the tens digit. So 6 into 3. 6 into 3 is 18. So you'll take 8. So the last two digits of this number will be 81. Okay, this also comes from binomial. So if you want, you can go back and check and understand how this has been derived. But a very, very important derivation, and this we are going to use very heavily. Okay, so I'll just repeat. For any number ending with 1, the last digit will obviously be 1, and the second last digit will be, you'll get that from multiplying the units digit of the power and tens digit of the number. Units digit of the power and the tens digit of the number. Whatever is the product, you take the units digit of that, that becomes your second digit or the tens digit. Fine. Okay, so this is 1. So we have looked at 1, we have looked at 5, and we have looked at 0. These 3 we have looked at so far. Okay, then let's look at the remaining odd numbers, which is 3, 7, and 9. Okay, so basically what we do here, as I told you, basically we will finally use the concept of 1. So convert the number by repeatedly squaring until we get the units digit as 1, then apply the rule of 1. That is what we do. So you'll have to go back to 1. For example, 79 to the power 64. Now 79 to the power 64, if I have to solve, 9 square is 81, right? So I can get 1 by squaring it. So what I'll do is I will do 79 whole square and this whole square 32. Okay, so inside I have 79 square. Now for 79 square, I should find the last two digits, not one digit, but you should find the last two digits. Now you'll come across a lot of questions like this. So please understand once, how do you multiply such that I get only last two digits? So whenever you have multiplication like this, and this is a square, but this will apply to any case. So we'll take another case also, but remember this method. Last digit will be product of these two. 9 into 9, you'll get 81 and carry will be 8. Second last digit will be product of the extremes and product of the means, and then you will add them. Okay, so 7 into 9 is 63. That is the extreme. 9 into 7 means is also 63. 63 plus 63 is 126, and 126 plus 8 was the carry from previous one. So 126 plus 8 is 134, so 4. And remaining you don't have to bother. So you basically get 41 raised to the power 32. Hope you have understood this. Let me take another number, 79 into 43. It is not a perfect square, but understand this concept. So the first place will be 9 into 3. You'll take the right hand side digits, or you'll take the units digit. So 9 into 3 is 21. 9 into 3 is 27, and you have carry of 2. Then you multiply the extremes, you multiply the means. So 7 into 3, you get 21. 9 into 4, you get 36. right? So 36 plus 21 is 57, 57 plus 2, 59, so 9, and remaining I'm not concerned. So that's how you will get the last 2 digits wherever required, and we'll need that a lot of times. Okay, so my number translates to 41 to 32. Now the last date is 1, so I can apply the concept that I had learned in the previous slide. My last date is going to be 1, and my second last digit will be the product of the units digit and the tens digit. So 4 into 2, 8. So my last 2 digits of the answer will be 81. Okay, so this is something that you're going to apply for any number ending with 3 or 7 or 9. Finally, they will give you 1, right? 3 ka fourth power will give you 1, 7 ka fourth power will give you 1, 9 ka second power will give you 1. So for 3, 7 you might have to go up to fourth power. For 9 you'll have to go to second power and you'll get this. And once you get 1, then you know what to do, right? So this takes care of now 0 we have learned, 1 we have learned, 5 we have learned, 3 we have learned, 7 we have learned, 9 we have learned. So all the odd numbers done, right? Okay. Let's do a couple of questions and then we'll move to even numbers. Okay, so find the last 2 digits of 87 to the power 43. Okay, so it is 87. 7, ideally you know that you will need fourth power, but let's do second power, but also the power is 43. It is not even number. So it's slightly tricky. What you'll have to do is take 87 out. Then you'll have 87 to the power 42. So 187 I'll have to take out. So this will become 87 into 87 square to the power 21. Okay. Now 87 square. That means 87 into 87. And this in some time you should be able to do it manually, especially when it's a square. The first digit is square of 7, which is 49. So 9 and 4 carry. And second digit is basically, because it's a square, it is 8 into 7 and again 8 into 7. So basically multiply the 2 digits and double them. So 8 into 7 is 40, 48, 56. Double of 56 is 112. 112 plus 4 is 116. So you'll get 6. Right? So that is what you'll get as the last 2 digits. Okay, once again, 7 into 7 is 49. So 9, 4 carry. And then 8 into 7 plus 8 into 7, which is same as 8 into 7 and then doubling it. So 8 into 7 is 56. Double of 56 is 112. 112 plus 4 is 116. So 69. Okay, so this is now 87 into 69 to the power 21. Now 69 square will give you 1. But again, you see the power is 21. So it's again not even number. So again, you'll have to do 87 into, you'll have to take 169 also out. Then you'll have 69 square to the power 10. Okay. And now 69 square, using same logic. 9 into 9 is 81. 8 carry. Then 9 into 6 is 54. 54 plus 54 is 108. 108 plus 8 is 116. So that will give you 6. So you'll have 61 as the last 2 digits. So 87 into 69 into 61 to the power 10. Okay. Now for this part, the last 2 digits will be 1. And then what do you multiply? I hope you remember the units digit of the power and the tens digit. So 6 into 0 will give you 0. So you get 0, 1 from here into 69 into 87. Now we'll need to multiply them also. So let's multiply these two. What will be the last 2 digits? 7 into 9 is 63. So 3 and 6 carry. Then 8 into 9, 72, plus 7 into 6, 42. So 72 plus 42 is 114. 114 plus 6 is 120. So 0. So you get 03 into 01. Okay. Again multiplying them using the same concept. 3 into 1 is 3. and then 0 into 1 is 0, 3 into 0 is also 0, so you get 0, 3. So your last two digits are going to be 0, 3. Okay, so that is all the concept put together. If you see, we have done so many different small things. Okay, first power was 43, not even power, so we had to take 187 out. Then we 87 square, we last two digits are 69. Then 69 again is 21, so we had to take one more 69 out. Then 69 squared to the power 10. Then 69 converted to 61, and then 61, because it is ending with 1, we know that my last two digits are going to be 0, 1. So then you have 87 into 69 into 0, 1. 87 into 69, last two digits are going to be 0, 3 into 0, 1. Now this you could have multiplied in any sequence. You could have done this first and then multiplied with 87. So that sequence, of course, is up to you. You will end with the final answer of 0, 3. Okay, so good question, where I think most of our concepts have got used. Okay, so let us move forward. Number 7 is slightly special, though 7 can be done using the previous method also, but 7 has a cyclicity for the second last date also, and this also is useful. And we can use this part also. If you see, 7 raised to the power 1 is 0, 7. I'm looking at last two digits now. 7 square is 49, 7 cube is 43, 7 to the power 4 is 0, 1. And then again it repeats. So actually the last two digits, when a number has 7 as the last digit, is 0, 7, 49, 43 and 0, 1. Okay, so 7 is the only number that has a cyclicity for the last two digits. Okay, so we can use this also, or you can use the previous method where 7 you raise it to a power till it becomes 1 and then you can solve it. So that is also fine, but this concept also is useful. Okay, but you'll have to remember that 7 has this, and if you do not remember what are those powers, what are those last two digits, that's not difficult. You can manually calculate. 7 to the power 1 is 0, 7, remember, is not 7, irrespective of whatever comes before 7. Then 7 square we know is 49. 7 cube is 49 into 7 is 343, so you write 43, and 7 to the power 4 is now 43 into 7, so 7 into 3 is 21, 2 carry, 7 into 4 is 28, 28 plus 2 is 30, so 301, you write 01. Okay, so 7 has this property. So let's say the question is, what are the last two digits of 7 to the power 2008? Now this we will solve using both the concepts. Let's solve this using what we just learned, and let's solve it using the reducing 7 so that it becomes 1 in the end and we get the answer from that. So we'll solve it using both. So 7 to the power 2008, I know that 7 has a cyclicity of 4. So 2008 divided by 4 will give me remainder of 0. That means my answer should be the fourth one. What was 7 to the power 1? 0, 7. 7 square 49. 7 to the power 3 is 43, and 7 to the power 4 was 0, 1. So obviously answer will be 0, 1. So this can be done very fast if you remember this. But if you don't remember, then what will you do? We'll convert this to 7 square to the power 1004. 7 square is 49. So you have 49 to the power 1004. 49 will be converted to 49 square to the power 502. 49 square is how much? Last two digits. 9 into 9 is 81. So 1, 8 carry. 9 into 4 is 36. Double of 36 72 plus 8 is 80. So 01 raised to the power 502. Okay, and in case of 01, you know number in ending with 1, so last date will be 1, and the second last date will be the units place multiplied by the tens place. So 2 into 0, it is going to be 01. So this way also this can be solved. Both the methods are fine. Okay, so for 7, this is a duplicate, or this is a second method, but a faster method. And all you have to remember, and even if you don't remember, you can calculate this very easily: 7, 49, 43 and 1. is what you get. Okay. Then, so we have done all the odd numbers, we have done 0 also. Now, what is remaining are your even numbers. So for even numbers, let's understand this. Note these outcomes. This, if you remember, that will be very useful. 24 raised to any odd number is always 24. So 24 to the power 1, raised to any odd number, 24 raised to the power 1 is 24. 24 raised to the power 3 is also 24. But 24 raised to an even number, 24 square is 576. So it is 76. Okay, and 24 and 76 again are complementary. They add to 100. So all that you have to remember is 24 raised to an odd power is 24, 24 raised to an even power is 76, and 76 raised to any power is always 76. Okay, this is useful because a lot of times you will get 24 or 76 in the end, and if we remember this, we can always write the answer directly rather than going through the longer method, which I'll explain you now. Okay, also it will be useful to remember the powers of 2. 2 to the power 1 is 2, 2 square is obviously 4, 2 cube is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is, and I'm only writing the last 2 digits, is 28, 2 to the power 8 is, now just multiply 28 into 2, 56, 2 to the power 9 is 56 into 2, 112, so 12, and 2 to the power 10 is 1024, so 24. So if you remember till here, that will be useful. Okay, we can write all the numbers so that you remember. Okay, but what is important for us are the last 2 digits. Okay, so 24 raised to odd power is 24, 24 raised to even power is 76, and 76 raised to any power is 76. That's first thing that we remember. And then basically what do we do? If you see, we use these rules to solve for any even number raised to any power. For example, 62 to the power 48. So 62 to the power 48, what we do is we basically convert every even number into an odd number by taking all the powers of 2 out. So 62 to the power 48, 2 to the power 48 is taken out, and 31 to the power 48 is separate. Now 31 to the power 48 we know how to solve. We just learned that, right? So this is ending with 1, so this will end with 1, and then you will have 8 into 3, 24, so 41. Okay, so the last 2 days will be 41 for 31 to the power 48. What remains is 2 to the power 48. Now 2 to the power 48, what I can do? I can do it in various ways. 2 to the power 48 I can write as 2 to the power 40 into 2 to the power 8. 2 to the power 40 can be written as 2 to the power 10 to the power 4 into 2 to the power 8. Now 2 to the power 10, you should remember I told you just now the last 2 digits, which is 24. So it is 24 to the power 4 into 2 to the power 8, which is 56. Okay, this is 24 raised to an even power. 24 raised to an even power is 76. So 76 into 56, right? How much will that give you? 6 into 6 is 36, 3 carry. Then 7 into 6 is 42, 6 into 5 is 30, 42 plus 30, 72, 72 plus 3, 75. So you have 56. So you get 56 from here. So your final answer will be 41 into 56. We again cross multiply. 6 into 1 is 6. 6 into 4 is 24. 5 into 1 is 5. 24 plus 5 is 29. So you have 96. Okay. Here it has been solved slightly differently. 2 to the power 48 has been converted to 4 to the power 24, which has been converted to 16 to the power 12. Now 16 to the power 12, for 16, basically if I take 16 square, we will remember that. Okay, but in case you want to know the last 2 digits, basically it's 16 into 16, that is 6 into 6, 36, 6, 3 carry, You have 6 plus 6, 12. 12 plus 3 is 5. 56. So it is 56 to the power 6, which again, 56 again, you convert it 56 into 56. So you have 6 into 6 again, 36, 6, 3 carry. And then you have 6 into 5, 30, 30 plus 30, 60, 60 plus 6 is 60 plus 3 is 63. So you have 36, 36 cube, which is again 36 into 36 into 36. So 36 into 36, 6 into 6 is 36, 3 carry, 18, 18, 36, 36 plus 3 is 39. So 96 into 36, which will finally give you 56. So there's so many ways of doing that. Okay. But remember that even has to be separated, odd has to be separated, odd has to be done what we learned just a while back, that you'll have to convert finally to some power of 1. And for even, you will have powers of 2 only. So powers of 2, we know these values. We know these. Using this, you should be able to do it very, very easily. Okay, great. So let's do a question here. Find the last 2 digits of 126 to the power 126. First thing, this one does not matter. Okay, so basically it's 26 to the power 126. Don't bother about that. Okay, so now when I have 126 to the power 126, right now we'll keep everything. So basically this can be converted to 2 into 63 to the power 126. So I'm separating it. So it is basically now 2 to the power 126 into 63 to the power 126. Okay, we'll solve for them separately. So first let's solve for 2 to the power 126. 2 to the power 126 can be written as 2 to the power 10 into 12, that is 120 into 2 to the power 6. 2 to the power 10 is 24. 24 raised to an even power is 76. Okay, and 2 to the power 6 is 64. Okay, so that is what you get. So 6 into 4 is 24. 4, 2 carry. 7 into 4 is 28. 6 into 6 is 36. So 36 plus 30, 66, 64. 64 plus 2, 66. You will get 64 as the last 2 digits. Fine till here? Okay. Then let's focus on 63 to the power 126. For 63 to the power 126, let's take 2 in and let's convert this to 63 square to the power 63. Okay, 63 square, what do you get? 3 into 3 is 9, 6 into 3 is 18, 18 double is 36, so you'll get 69. So 69 to the power 63, which will get converted to 69 into 69 square to the power, so 169 is out, 63 power becomes 62, so it becomes 31. Now 69 square is how much? 9 into 9 is 81, 8 carry, 9 into 6 is 54, 54 plus 54 is 108, 108 plus 8 is 116, so you get 61 to the power 31. Okay, so this has converted to 1, so 1, and then the units digit and the tens digit, 6 into 1 is 61, and then we had a 69 here. Okay, so 9 into 1 is 9, then 6 into 1 is 6, and 9 into 6 is 54. 54 plus 6 is 60, so 0, so 09. So 64 into 09. So that gives me 9 into 4, that is 36, then 3 carry. So 9 into 6 is 54, and this is 0. So 54 plus 3, 57. So your answer is 76. Okay, so longish method, but you have used all the concepts. Even you have taken out, so you have used the concept of 2. 63 you have taken out. 63 you converted using squaring it, you converted it to 9, 9 squaring it, you converted it to 1, and then you use the concept of 1 to get the answer. So one thing that you must understand here is, using this approach, you can get the tens digit for any number, because we have covered everything. You know for 0, you know for 1, and 1 is the most important, because finally all odd numbers 3, 7, 9 are converted to 1. 5 has a separate rule. 5, we saw that 5, depending on odd, okay, I hope you remember that odd into odd will give you 75, all others will give you 25 as the last two digits. What is the second last digit and what is the power? Okay, so 5 will give you 75. So 5, because 5 you can't convert it to 1. Okay, and 7, there's a separate rule also, that 7 follows a pattern of 07, 49, 43 and 01. So all these done, and then your 2, 4, 6, 8, you'll take 2 out from them to convert them to odd, and then you will solve it using this method, right? Okay, let's do a couple of more questions. So find the last two digits of 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial up to 100 factorial. Okay, so 1 factorial obviously is 1, 2 factorial obviously is 2, 3 factorial obviously is 6, 4 factorial is 24, 5 factorial is 120. Okay, 6 factorial is 720. 7 factorial is 5040. We need to do this till where? Of course, not till 100 factorial, right? So you'll need to do this till you start getting 0 at the second place. See, we have started getting 0 at the units place. After some time, once we get one more 5, you will get 0 at the tens place also. And then it does not matter. Okay. And where will you get that? 10 factorial, because 10 factorial will be 10 into 9, 8, 7, 6, 5. So 10 factorial will have 2 5s. And hence 2 5s will make it 100. So 8 factorial is, and again remember, you don't have to write the full number. If you want, you can just write the last two digits. So for example, 7 factorial, the last two digits are 40. 8 factorial, this 40 basically gets multiplied with 8, right? So 40 into 8 will become 320. So just 20 is also good enough. 9 factorial is this 20 gets multiplied with 9 now. So 20 into 9 is 180. So it will be 80. And 10 factorial, this 80 will get multiplied with 10. It will become 800. So 00. After this, all the last two digits are going to be 00. So you don't have to bother. So now if I look at the units place, what do I have at the units place? 1 plus 2 is 3. 3 plus 6 is 9. 9 plus 4 is 13. So units digit is 3 and there's 1 carry. After that, you can see there's nothing at the units place. Then at the tens place, I have 2. 1 was carry. So 3. 3 plus 2, 5. 5 plus 2, 7. 7 plus 4, 11. 11 plus 2, 13. 13 plus 8, that is 21. So 1. So my last two digits are going to be 13, and hence my answer is second choice. Okay, so all such long expansions, there will be a pattern after some time, and you only have to solve till you get that pattern. After that, you don't really have to bother. Okay, so that is, the pattern has to be identified. Once you identify that, then it becomes very, very simple to do these questions. Okay, so if the question was only about the last digit, we could have stopped here. The question is about the second last digit, we have stopped here, because after that the last digits will become 0. If the question was about last 3 digits, understand there also you'll have to go till 14 factorial, because 15 factorial will give you third 5 and that will give you third 0. Okay, so you'll have, then 3 zeros will start, then from 20 factorial 4 zeros will start, then from 25 factorial you'll have more zeros. Okay, great. We are going to, in the next class, we are going to look at factorial in more detail, and we are going to solve many more questions using the concept of factorial. But here the main focus is on last digit and last two digits. Okay, fine. Let's look at this. What are the last two digits of the product? 125 into 126 into 127 into 128 into 129. How do we find the last two digits here? So I'm sure you know what is to be done here. You basically will have to combine them finally into a single number. So let's say I take, and you don't have to bother about the digit at the third place. Okay, so it is 25 into 26. What does this give you as the last digit? 6 into 5 is 30. So 0, 3 carry. Then you have 6 into 2, 12. 5 into 2, 10. So 12 plus 10 is 22. 22 plus 3 carry is 25. So you get 50, right? So these two give you 50. Similarly, what do they give you? 27 into 28. So 8 into 7 is 40, 48, 56. So 6, 5 carry. Then 8 into 2 is 16 and 7 into 2 is 14. 16 plus 14 is 30. 30 plus 5 is 35. So 56. So they give you 56. And you have 129, which is basically 29. So I can combine that with any one of them. So let's say I combine these two. 56 into 29. If I look at this, this is 9 into 6, 54, 4, 5 carry. Then 9 into 5 is 45. 45 plus 5 carries 50. 50 plus 12 is 62. So 24. So this gives me 24. And this was 50. So now I have 50 into 24. 50 into 24 will give me 4 into 0 is 0. And then 5 into 4 is 20 plus 0. So 20, that is 0. So this is going to be 0, 0. Okay. One more thing that we could have noticed, the answer is 0, 0 obviously. But if you see here, 125 is what? 125 is 25 into 5. Or 5 cube. So this already is 5 cube. Now, every 5 needs a 2 to give you a 0. Right? So you can see 126 has a 2. 126 is equal to 63 into 2. So you get 1, 2. Only 1, 2 because then 63 is odd. But 128 is 64 into 2. And 128 actually is a whole khajana of 2 because 128 is 2 to the power 7. So it has so many 2's. Okay, so 2 is not in short supply. 5 is in short supply, but 5 also have 3 times. No other 5. So actually I can make 3 pairs. I can make 3 pairs of 5 and 2. That means last 3 digits are going to be 0 for this number. So you didn't really have to do all this. If you see 5 anywhere in number, and most likely 2 will also be there, but just be sure. And every pair of 5 and 2 will give you a 0. And here you can see that you have 3 pairs of 5 in 125. You have 1 2 in 126. And you have 7 2's in 128. So you can make 3 pairs. So that means you will have 3 zeros in the end. So last 2 digits obviously are going to be 0, 0. As simple as that. Okay. So that brings us to the end of this concept, which was your cyclicity and finding out the last digit and the last 2 digits. Okay. I hope you enjoyed the class. Please go through, take down notes and remember the method, because the method that I've given you, the best part is you can solve and find the last 2 digits for any given number. Okay, there's nothing very specific, any given number. 7, there was a specific case. 24, there was a specific case, but then you have the general rule also, which you can anyway apply. The specific cases can help you get your answer faster, but the general rules are there. Use them, get your answers, and then see you in the next class where I'm going to take up concepts related to factorials. Okay, 2 core concepts remain. One is factorial, and then in the next class we are going to look at concepts related to remainders, which is again very, very important. Okay, thank you so much. So Nishant here signing off. Take care. Bye-bye.